Welcome student to my channel Educare Maths and Science. Today I just discussed the continuation of the physics. This is the left part, the motion in one dimension. On the continuation of this, today I discuss the other physics. The gravitation is a very important concept. Gravitation. Okay, you know all this thing in case of the Newton's. All these thing. If you just do this, is attract towards the center. These are actually the natural phenomena. So on this discussion, Newton's act or work on it, and the difference formula is developed from there, and the concept is clear. Just a details writing here for your time saving and the clear conception. Then you continuation of the basis of these different mathematical problem. Okay, so first you clear the concept. So what is this? The physics, the gravitation. This is especially the class 9 I.C.S.E, C.B.S.E and all these things. And now the starting here, the main thing is there. This is a natural phenomena before the Newtons and all these things, from the starting from the universe. This is the main concept. Each mass particles of the universe attracts to other mass particles. This is a natural phenomenon. It's very important thing. Two mass in the universe is attract each other. Always. This is a natural phenomenon. Each mass particles of the universe attract other mass particles. This is a natural phenomenon. On the basis of this, Newton's follows and then we developed the Newton's law of gravitation. Attraction is always the universal. But what is actually the reason and what is the mathematical calculation of the concept that is developed by the Isaac Newton? This is a very important renowned scientist, Isaac Newton. The force of attraction between two bodies. Suppose we just draw. Suppose you just see, here is a body and here is a body. Suppose this is M, this is small m. This attract this body attract this, and the same force, this body attract this. This is the very important. That is the natural phenomenon. Now, Newton's law of gravitation, the force of attraction between two bodies. These two bodies are universal body, and this force is attract this body, and this force also attract this body. But what is the law? What is the law maintains here? Okay, this is the very important thing. So one is directly proportional to the product of the masses. The force of attraction, suppose this is F, and this, how many forces develop? That is actually the depends on the masses. The directly proportional to the product of the masses, multiply of the masses. One is this directly proportional. This is the Newton's law. Newton develops. And inversely proportional. Inversely means just decrease. Inversely proportional to the square of the distance. If the distance from the there to there, suppose this is R. So inversely proportional to the square of the distance. If the distance is very near to each other, the force of attraction is high. If the the distance between far above from this, suppose here is two bodies, the force of attraction between this, but if the body is very close to each other, the force of attraction is increased. Due to the distance is decreased. This call actually the inversely proportional. Okay, the force of attraction here is, suppose this is the R is the distance, F1 is the mass, force developed, here is F2 is the force developed, but the two forces are same. Now, this is M actually, this is M1 and this is M2. What is the Newton say? Force directly proportional M1 into M2. That is the mathematical deduction. Directly proportional M1 into M2. Product of the two masses. And inversely proportional to the 1 by, inversely means 1 by, distance, square of the distance. That means R square. If you just, in case of the variation, directly proportional this, inversely proportional this, if you just write together, to F direct proportional to M1 M2 by R square. That is the mathematical deduction. From there, you know, in case of variation, the mathematical. So this is some constant G. So F is equal to G M1 M2 by R square. From there, the G, the gravitational constant is developed here. This is very important. So actually, in case of the gravitational law, if the force of attraction between the two bodies in the universe, they attract each other, that is the natural phenomena. I just repeatedly say, it's not discovered by the Newton. Newton's developed the law. In which way, what is the value of this? That is discovered. That is the law. The force is developed in which way? That is deducted by Newton. The M1 into M2. That is the product of the two masses. The force is developed. Force is developed in nature. The two bodies in the universe attract each other always. Before the Newton also this. But in which way the force is developed? How much force is developed? That is by Newton. The product of the two masses, if the masses is very small, the force is very small. If the masses are very big, the force is developed very big. And one other thing, the difference. Suppose here is two body. If the attraction of these two body is very close, but if this is that far, the attraction is less. Okay, very close the distance. Okay, so this is the mathematical reduction is directed by the Newton. F directly proportional to the m1 into m2, that is the multiplication, the product, and the inversely proportional of this in the variation. This is the same thing. You just m1 m2 by r square. Now the sum, the gravitational constant g is calculated here. So F is equal to G m1 m2 by r square. This called the G is called the gravitational constant. And now the value of G remains same at all places, independent. The value of this universal constant for that reason, total universe, the G of is constant. But this is independence on nature of particles. What is the particles? What is the nature of the particle is indifferent. G is always constant. Temperature is cannot change in the case of the temperature. The temperature is difference. The G is not different. G is always constant. And the medium. These are all indifference. So for that reason is called the universal constant. Okay. And here is the force is developed F1. Suppose there is a force is developed F2. F1 is equal to F2. That means this mass is attract F2 force, and this force attract its in the F2 force. So F1 and F2 are same, equal and opposite. F1, that means this force, that means this mass attract this one by F1 force, and this mass attract this by F2 force. Just opposite, but the F1 is equal to F2. Same force is developed. এইটা একে F1 এ অ্যাটাক করছে, এটা একে F2 এ করছে, but the same force, but the equal and opposite. Now in which way you just calculate the G, just you calculate in different things, but the value of G is deducted is 6.67 into 10 to the power minus 11 Newton meter square kg cube. It is calculated actually if this is 1 meter, this is 1 kg, this is 1 kg. From there you calculate G. Okay, no problem at all. Okay, the mass, if you just all the units, you just take all the units. If you just take all the units, you calculate this. Okay, if mass is 1 kg, m1 is 1 kg, m2 is 1 kg, r is 1 meter, then you calculate this. From there you calculate the value of G. Okay, unit. So the ultimately the G, you just remember G is equal to 6.67 into 10 to the power minus 11 Newton meter square and kg to the power minus 2. This is the value. Now, highly significant to the between heavenly bodies. This is the universe. Heavenly body, there is a mass is huge. Here is very applicable the G. Very applicable to the force. Huge mass. The force is huge developed. So there is very applicable, but is very insignificant. It is a very ordinary body. Suppose 2 kg, 1 kg, 3 kg, and this is a 5 kg. The mass is developed very subtle, very small, but in the universe, the huge between the two stars, two planets, the attraction between them is huge because the huge or the large amount of masses. For that, it is very much applicable. So this is called the universal constant is G, and this is called the force of gravity or the gravitational force, very much applicable to the universal bodies or heavenly bodies, but very insignificant the small body. Okay, it's clear to you. Now one thing is there, force due to gravity, due to the if each and every one, if you just close this, it's always attract to the center. That means always here earth is a heavenly body and one object is a heavenly body. So earth attack the body, earth attack this body, and this body also attract the earth. So here is earth attract every object. Earth, this is a force due to gravity. Earth attract every object around it towards the center. One very much important thing, the body also attract the earth. This is very important. These are both of the heavenly bodies. But earth attract every object around it towards the center. Suppose this is the earth. Suppose this is the earth. This is the radius of the earth. This is the body. So these bodies attract towards it. This is the earth. This is this. So these bodies attract toward the center. At the same time, the same force is developed, and this body also attract the earth. So what is the force developed? That is calculated. Okay, first one. the mass of the earth, huge amount, 5.96 into the power 24 kg is the mass of the earth. What is the radius of the earth? 6.37 into 10 to the power 6, the radius of the earth. Mass, suppose your mass of the body is 1 kg. So what is the force developed? What is the force developed? So you know the formula, F is equal to G, capital G, M, capital M, mass of the earth, M2. That is the mass of the body, and R square, R is this. So you just put the value. G, the value is 6.37. This mass of the earth is 5.96 10 to the power 24, and radius. So this is square. Ultimately, that is the calculate is 9.8 Newton. That means a heavenly body, that is the 1 kg, in which force earth is attract toward the center. In which force? Suppose if this is the 1 kg. So what is the force attract toward the center? This is the 9.8 Newton. Is okay to you? For that reason, it's attract toward the center. But at the same time, this 9.8, it force of attraction attract the earth also towards it. That means this body is attract the earth at the force of 9.8 Newton. But earth is not moved because the huge amount, the huge inertia. For that reason, this body towards the center, but earth is not its center, because it is the very small amount and earth is a very huge. For that reason, the greater energy, greater inertia. For that reason, the earth is not moved. Is clear to you? Each and everybody attract. This body attract earth also. Earth attract this body. Suppose it is a 1 kg. Earth attract this body towards the center is 9.8. It's fall. But at the same time, this body attract the earth 9.8 Newton. But earth cannot move because a huge amount, huge mass, inertia is used. For that reason. Okay. Now, this is the calculation. Here is the body. So this F1 is, this is the body, this attract here in this 9.8, but at the same time earth attract by the body this 9.8, but earth is not moved. Why? The object also attract the earth towards the center, towards it with equal force. That is the very important. The object also attract the earth towards it by the center, the same force. Okay, why body is moved, earth is not moved? This is a very important question, because first one, the object is force, the object is free to move, because it is not tight, it's free to move. Small inertia because of small masses. This is a very small mass, small inertia. For that reason, but this body attract the earth the same force 9.8. Okay. Why earth is not moved? Because the large inertia, huge mass, because you know the mass of the earth is this, and mass of the body is 1 kg just. So huge inertia developed. Okay, huge mass. So does not move towards the object. For that reason, earth is not moved towards the object. So this is the basic concept. You know the gravitation, you know the force of gravitation due to the gravitation, the acceleration due to gravity in the next video. Okay. So main thing is this: if the body is there and this there, it's suppose the earth is there, body is there, it's moved here in this way, but earth is not moved because the huge inertia. And what is the calculation is this, and what is the concept of the Newton's law? On the basis of this, you gradually increase the mathematical part of this. Okay, so this is the clear concept, and you just remember the G, and the main thing is the concept in case of physics. In the detailed idea, if you just clear your concept, that will be very helpful to you the solving the sums. Okay, so this is the main concept. So this for today. If you just understand, please share and subscribe the channel. Thank you student. Thank you.